All right, so now that we've talked about stage 3 and how we're never going to produce in stage 3 because we're going to increase costs and essentially we're going to decrease output. Doesn't make much sense. We're going to try and, if we do produce in stage 1, we're going to try and move out of it relatively quickly for the simple aspect that we're going to capitalize on the added efficiency, and we're going to work to that point where we're most efficient per our unit of input. And that's right at the point where marginal physical product intersects the average physical product. So stage 2 is the area that you actually want to produce in. That is going to be the optimal area that you want to produce in because, and here's a couple of reasons why. One, you have capitalized upon the efficiency of stage 1, but you are not decreasing output like in stage 2. So that brings up a good question though. Why would you not stop at the end of stage 1 since this is the most efficient point? Why wouldn't we just produce at the most efficient point and call it a day? Because by increasing input use into stage 2 means that you're still increasing your production. You're still going to get a higher level of production in stage 2 than you would of in stage 1. Even by producing at the end of stage 1, even though that's the most efficient, we're not maximizing production. Maximizing production is actually at the point where we transition into stage 3. But we also may not want to maximize production either because of the additional cost. So at what point are we going to be producing in stage 2? Well, we're going to increase production increasing production actually increases the additional revenue. By operating in stage 2 and increasing our total production, we're increasing our additional revenue. But by increasing total production, we're increasing the use of our inputs, which also increases our costs. So as we're going through this, as we move further down this graph, as we move to the right until we hit the beginning of stage 3, our total product is going up. So we're increasing our revenue by total product, but we're also using more labor, which means that we're also increasing our input costs. So you will expand into stage 2 as long as the additional revenue outweighs the additional costs. So somewhere in stage 2, when we're in stage 2, the additional revenue is going to outweigh the additional cost. And as long as the additional revenue outweighs the additional cost, guess what? We're going to keep producing more. Because let's stop and think about that. If you can receive $5 and it only costs you $3 to make it, why not produce it? That's $2 extra of profit. What about if it costs you $5 to make it, $5 in revenue and that additional revenue to sell that item, but yet it costs you $4? That's still $1 profit. So you're going to go ahead and produce at that point. So as long as the additional revenue outweighs those additional costs, we are going to continue to produce or increase production in stage 2. But we'll find at some point in time that we hit that profit maximizing point within stage 2. So within stage 2, the marginal physical product is continuously decreasing. And this is actually a frequently observed phenomenon. And it's so frequently observed that we actually have established it as an economic law. This economic law is known as the law of diminishing marginal product. So law of diminishing marginal product says as successive units of variable input are added to a production process with other inputs held constant, the marginal physical product eventually decreases, which means the rate of growth, the rate of change, the rate of the growth for that total physical product is going to decrease. So let's stop and think about it using a fertilizer example. I used this one earlier, but we're going to go ahead and touch on it again. If you add just a little bit of fertilizer, the plant uses it and begins to grow. So actually, if you use a small amount of fertilizer, you're going to see a rapid growth in that plant. So you think, oh, fertilizer is good, which it is. It's a modern technology advancement that helps plants grow and be more efficient. So we said, well, that little bit of fertilizer made it grow a whole bunch. So we're going to add a little bit more fertilizer. But as you add more fertilizer, the less the plant actually needs and the less effective each additional amount of fertilizer becomes. So that rate of growth begins to fall. That effectiveness of each additional unit of fertilizer begins to decrease. Meaning the plants have maybe they've maxed out on their amount of nitrogen. Maybe they max out on their phosphorus or potassium or something like that, where they don't need as much. They've already gotten, whenever you first apply that fertilizer, they were highly deficient in all these nutrients. And because of that, they sucked it up and they used that fertilizer real well. But as you continue to use more, they don't need as much. And as they don't need as much, they begin to actually use less of it, making the effectiveness of each additional unit actually lower. But the plant is still growing, so you keep adding fertilizer. But even though it's growing, it's not growing at the rate that it was before. Then something happens. Then you actually think that, oh, fertilizer is still good, but you add too much. So what happens when you add too much fertilizer? It actually can burn the plant and die. So that is the point where marginal physical product actually goes below zero. Whenever total physical product actually falls. That's whenever you add too much of that fertilizer. This first aspect that we talked about right here, that's whenever marginal physical product is increasing. That total physical product is increasing at an increasing rate. Whereas in this segment right here, that's whenever we said that marginal physical product was actually decreasing and total physical product was increasing at a decreasing rate. And we see this across all different types of inputs. We've used the example of labor. Now we've used the example of fertilizer, and you can apply that to machinery. You can apply that to fuel. You can apply that to virtually all different types of inputs. To chemicals is another good example. Pesticides, herbicides, things like that. You can apply that to almost every single input and see this same trend where we have our total physical product would do something and make that curve right there and then actually begin to fall. And we have our output over there and our input on this part of the graph. And we're going to see that same trend happen across virtually every single input. It does it so frequently that we've given it a name. And we've named it the law of diminishing marginal product. The law of diminishing additional output. Remember, a marginal means additional. Product means that output. So that law of diminishing marginal product is the name for that phenomenon. Whereas we use more of an input, the effectiveness will eventually fall.